The ocean hides many secrets, but off Florida's coast, scientists have uncovered a threat that could change everything. On a routine mapping mission, marine researchers discovered colossal sinkholes on the seafloor, some stretching for miles. These aren't just geological oddities, they're active, dynamic voids beneath one of America's most vital coastlines. Initial reports were so alarming they were thought to be errors, until the data was confirmed again and again. The Sunshine State is now perched on the edge of a vast, unstable chasm. This network of underwater sinkholes, some ancient and others actively collapsing, signals a volatile system right beneath our feet. The implications are staggering. From maritime safety and offshore infrastructure to the survival of Florida's unique marine ecosystems, the ground beneath the sea, once assumed solid, is now revealed as fragile and treacherous. This discovery has triggered an urgent response, a race to understand the magnitude of the threat and what it means for millions living along the coast. What caused these sinkholes, and what happens if one collapses catastrophically? Florida is facing a danger no one saw coming. So what is a sinkhole? It's a cavity formed when the ground collapses into voids created by dissolving rock. Florida sits atop limestone, rock that water slowly dissolves, forming hidden caverns over millennia. Normally these voids remain stable, but changes like drought or heavy rain can trigger sudden collapse. On land, the results are dramatic but localized. A house swallowed, a road vanishing overnight. Florida is already one of the most sinkhole-prone places on Earth. But now, scientists have found this same process happening offshore, on a massive scale, hidden beneath the ocean's pressure and darkness. The limestone extends under the sea, where the weight of the ocean and powerful currents make these voids even more unstable. Even minor tremors could trigger catastrophic collapses. We're not just dealing with holes in the ground, but massive, water-filled voids in the continental shelf. The forces at play are immense, and the risks unprecedented. It's a geological nightmare scenario unfolding beneath the waves. This discovery was only possible thanks to cutting-edge marine technology. The research vessel Odyssey, equipped with the High-Resolution Autonomous Bathymetric Sonar, HABS, mapped the seafloor in stunning detail. HABS, an autonomous underwater drone, uses multi-beam sonar to create precise 3D maps of the ocean bottom. The team expected sandbars or shipwrecks, but instead, they found a sprawling field of colossal circular depressions. To investigate further, they deployed Triton, a remotely operated vehicle with high-definition cameras and sensors. Triton's lights revealed sheer limestone walls and fresh fractures, evidence these sinkholes are actively expanding. Chemical sensors detected water with unusual salinity and temperature, confirming a direct link between the ocean and Florida's freshwater aquifer. The technology didn't just find the sinkholes, it proved they're alive, dynamic, and dangerously unstable. The seafloor is not just mapped but exposed as a living, shifting threat. Underwater sinkholes are far more dangerous than those on land. A sudden collapse could displace massive volumes of water, generating a powerful localized tsunami with almost no warning. These sinkholes act like giant drains. If one collapses, seawater could rush into the aquifer, creating violent currents and unpredictable hazards for ships and submarines. The environmental stakes are enormous. Florida's aquifer supplies drinking water to millions. A breach would cause instant, irreversible saltwater contamination, triggering a freshwater crisis. The sudden change in ocean chemistry and pressure could destabilize the seafloor further, causing landslides and more collapses. There's also the risk of releasing trapped gases like methane, potentially explosive and capable of sinking ships or creating toxic clouds. These aren't just holes, they're geological time bombs with multiple ways to detonate. The threat is invisible, unpredictable, and potentially catastrophic. Florida's coast is now a high-risk zone with dangers lurking just beneath the surface. The consequences could be felt for generations. The ocean's secrets have never been more dangerous. The discovery of these abyssal sinkholes puts all of Florida at risk. Millions living along the Gulf Coast could face a tsunami with only minutes' warning. Emergency systems aren't designed for disasters this close to shore. The economic fallout would be immediate. Ports closed, oil and gas pipelines severed, and the tourism industry devastated. Wildlife would suffer an extinction-level event. Manatees, sea turtles, and coral reefs wiped out by sudden changes in water chemistry and pressure. Toxic gases could create dead zones, shattering the marine food web. Property values would plummet, insurance would vanish, and the psychological toll on residents would be immense. The very idea of Florida as a safe, prosperous place is now in question. The state's greatest asset, its coastline, has become its greatest liability. This is not just an environmental crisis but a crisis of confidence and survival. The stakes have never been higher. In response, the U.S. government has enacted an unprecedented shutdown of Florida's Gulf Coast. Large sections are now federally mandated exclusion zones. No ships, no fishing, no recreation. The Coast Guard and Navy enforce a hard perimeter, closing major ports and halting maritime traffic. Mandatory evacuations are underway for the most at-risk coastal communities, displacing hundreds of thousands. Offshore oil and gas rigs are being shut down and evacuated to prevent environmental disaster. Even airspace is restricted, with flight paths rerouted to avoid potential gas releases. The decision is drastic, but the science is undeniable. The risk of inaction is too great. Federal resources are mobilized, from FEMA to the Army Corps of Engineers, to manage the crisis. The shutdown is a defensive measure, a painful but necessary step to buy time for scientists and engineers. Florida is now a state on hold, racing against a silent subterranean threat. With the coast cleared, scientists have launched an all-out effort to map and monitor every sinkhole. Research vessels, drones, and sensors swarm the Gulf, creating a real-time threat map of the seafloor. Sophisticated sensor networks, seismometers, tilt meters, hydrophones are deployed to detect the slightest warning signs of collapse. Data streams to a central command, where supercomputers analyze patterns and predict risks. Engineers are racing to stabilize the most dangerous sinkholes, using marine concrete and even considering controlled collapses. The future of Florida hangs in the balance. Science is advancing fast, but nature may not wait. Will technology buy enough time, or will the forces of the deep prove unstoppable? The next few months will decide whether this story ends in triumph or tragedy. Florida's fate, and perhaps the world's understanding of our planet's hidden dangers, is being written right now.